Hi, good morning and Assalamualaikum everybody. I am Amy Zarah binti Ahmad. I'm from University Kebangsaan Malaysia doing my postgraduate studies at Solar Energy Research Institute. So for today, I'm going to be talking about the heat sink effect on the parasitic resistance of photovoltaic modules. So, there are many concerns regarding the PV performance, and it is well known that the PV performance depends on the solar irradiance and as well as the module operating temperature. Because the electrical output power from the PV module will drop when the module operating temperature increase. Why? Because only 20% absorbed solar radiance is converted to electricity and the remaining is dissipated as heat. So what is parasitic resistance that we are concerning in this topic is actually this thing. So this is the equivalent circuit of a solar cell. Uh, as you can see, that this is the photocurrent generator and this is the diode separation. We call it the charge separator. So these two emulates the PN junction in a solar cell. So this RSH is the shunt resistance and RS is the series resistance. So this is the real solar equivalent circuit of a solar cell. If it's an ideal circuit of a solar cell, this shunt resistance doesn't exist. It's just a pure PN junction without these two resistor components. So this is by theoretically, we want I to be as high as possible by making this RSH shunt resistance higher and RS lower. So this can be realized through experimental, and in my case I've been comparing between the conventional PV module and the one with the cooling heat sinks. As you can see from here, the experimental setup was developed under the Malaysian climate conditions, and the setup consists of two identical modules, which is the monocrystalline, and to be precise, it is IBC, which is interdigitated back contact of 120 watt peak. So in this case, uh, this module inclined at 80 degree facing to the south, and the monitoring and measuring equipment based on the Malaysian standard IEC 61724-2010. So this IV curve tracer is a very important component in this study, which is used to measure the open circuit voltage, short circuit current, as well as the maximum power, current, and voltage. Whereas the weather monitoring station used to monitor the solar irradiance, the ambient temperature, as well as several inputs to the PV module, such as the module temperature sensors at several points. So this is the result that I got. On figure 4.1a, it's the ambient temperature. The gray line is the ambient temperature during the day, and this is the irradiance. The orange dotted line is the solar irradiance that recorded from 8 a.m. in the morning to 6 p.m. So it can be seen that during the early in the morning, it's a bit cloudy, hence the dotted the line is fluctuate a little bit. But the reading throughout the day is between 200 to almost 1000 watt per meter square. Um, yeah, but the ambient temperature is quite stable from 30 to almost 38 degrees Celsius. So the impact on the PV module with and without heat sinks is being presented in figure 4.1b, which is the temperature variations between reference and fin PV module. So from this figure, it shows that fin heat sinks demonstrate a significant impact on the module temperature reduction, especially at solar irradiance greater than 600 watt per meter squared. So this is the important part of the results and this discussion for this topic, which is from the measured IV curve, the following parameters were derived, which is the module efficiency, fill factor, and the shunt and series resistance. So to measure the series resistance, the value of VMP is divided to the VOC, and the value of IMP is divided to ISC to get the shunt resistance. So this is what we call the inverse slope method that normally being used to get the value of the derived parameters. So it can be seen that the orange and blue line, the orange one is the PV reference and the blue line is the PV with the cooling heat sinks. It shows that the study shows that a significant increase in shunt resistance, which is up to 5.39%, and series resistance increase only 0.89%. So it shows that a significant increase in shunt is desired to avoid the high current flowing through the parasitic resistance. Yeah, this is the reference. Yeah, that's all. Thank you.